doing good. And one thing I want to say here, actually I'm really very happy because in the last class I gave few applications as a homework, right? And you people did all those, and a few members shared the notes related to that one also. Very good, ma. So actually by that, so what I understand is simply yes, okay, you are listening the classes and this method is clear to you, okay? So please remaining people try to solve the homework problems, ma, and if you will get any doubts then ask me, okay? So yesterday we discussed one application, right? Of course, we discussed the bisection method and applications, and now here I am going to discuss some more applications. Actually, I gave homework also, right? Yeah. Now just put a side heading. Put a side heading. The method of false position. Method of false position. Method of false position. So again it is a new method, no? So in a previous method we discussed bisection method, and in that what we discussed simply the method, how we will solve the problems related to the bisection method. And after that what we discussed about applications, right? And first of all we discussed about the thing that is nothing but how we have to solve, and what is the procedure of the bisection method, and we discussed the general basic formula also, and with the help of the calcium we are solving the applications, right? So now here I am going to discuss the next thing is nothing but of course just see your syllabus copy, ma. See your syllabus copy, and in that what we have after bisection method we have the method of false position. So just give a second. Yeah. Now write down method of false position. Now in this write down this is the oldest method for finding the real root of a non-linear equation. Non-linear equation means the equation which is of the form f of x equal to 0. F of x equal to 0 equal to 0 and closely resembles the bisection method. Okay, so it is somewhat related to bisection. In this method, comma, it is also known as regular falsy, regular falsy. Okay, regular falsy, or our method of curves. Method of chord. Comma, right. We choose 2 points A and B. Such that f of A and f of B are of opposite signs See, generally similar to bisection method. In bisection method, what we consider, ma? One is positive and another one is negative now. So that's why similarly here also opposite signs are of opposite signs. Next, here, hence, a root must lie in between. A root must lie between these points. These points. Now write down. Therefore, the equation, next line. Therefore, the equation of the chord joining the 2 points. What are those points? Joining the 2 points a comma f of a and b comma f of b. Okay, b comma f of b is given by y minus f of a by x minus a. Y is, when you are taking y, then the function value, x means a value, okay, which is equal to f of b minus f of a by b minus a. Okay, so now this is nothing but the required equation. Okay, so now here consider it as equation number 1, otherwise no need, just box it. Okay, otherwise consider it as equation number 1, no need to write every time again and again. Okay, now write down. The method consists in replacing the part of the curve between the points a comma f of a and b comma f of b by means of the chord joining these points and taking the point of intersection of the chord with the x-axis as an approximation to the root. Okay, next slide. Therefore the point of intersection in the present case is obtained by putting y equal to 0 in equation number 1. So now see here, by substituting y equal to 0 here, what we will get here? Y equal to 0. Then minus f of a by x minus a equal to f of b minus f of a by b minus a. Right? So generally here, I am going to calculate the value of the x. Okay? So now here, I am going to calculate this one. Then simply what I get? X minus a into f of b minus f of a equal to, so then what we get, cross multiplication I am doing, okay, then minus f of a into b minus a. Now x minus a is equal to minus f of a into b minus a by f of b minus f of a. Okay, now x equal to, it is minus a, if it goes to the other side, plus a minus f of a into b minus a by f of b minus f of a. Okay, now write f of b minus f And now here what we can write? We have to write it as nothing but some x1. Okay. So simply here I put substituted y equal to 0, and after that I calculated for x. So now here I have that x1, and still we can solve this one, because by taking the LCM again we will get a new value now. X1 equal to a of f of b minus f of a minus f of a into b minus a by f of b minus f of a. So now here what we can write now? Directly a into, so now here I am multiplying. Listen, now a into f of b minus a into f of a minus b into f of a minus into minus plus a into f of a by f of b minus f of a. Just I am finding the formula, that's it. Now minus b, here we have plus a f of a minus a. So now here what is the formula? A into f of b minus b into f of a by f of b minus f of a. This is nothing but the value of x1. So now here what is the x1 value ma? Remember x1 means first of all we have to take a into f of b minus b into f of b by f of b minus f of a. Next write down. Now, which is, write down, next line, continuation, next line. Which is the first approximation, which is the first approximation to the root of f of x equal to 0. F of x equal to 0. Right on, next line. If f of x1 and f of x1 and f of a are of opposite signs, are of opposite signs, then the root lies between a and x1. Similarly, for the bisection method, every time we are checking the positive value and negative value, and by that we are taking the next interval number. So here also we have to take in that way only. Okay, x1 and continuation, and we replace b and we replace small b by x1, and obtain the next approximation. Otherwise we replace small a by x1 and generate the next approximation. Okay, next one. The procedure is repeated. The procedure is repeated till the root is obtained to the desired accuracy. Okay, next write down. In a simple way, write down. If f of x1 is greater than 0 and f of a is less than 0, then the root lies between a and x1. Root lies just now I said totally theoretically way. Now I am doing this one. Okay, now it is between a comma x1. Okay, so then what is the formula? Next formula is x2 equal to, now what you have to do? Same formula, a, f of b means in the place of b what they said, x1 minus again x1 into f of a is a only by f of b means f of x1 minus f of a. Okay, next line write down. If I said two cases, ma. Now I am giving the two cases formulas. If f of x1 is less than 0 and f of a is greater than 0. Is greater than 0. Then the root lies between x1 and b. x1 and b. Then what we have to do? We have to replace a with x1. Then x2 equal to x1 into f of b minus b into f of x1 by f of b means directly f of b minus f of x1. Okay. Now put aside in graphical representation. Graphical representation. Okay. So in this one we have to discuss the graphical representation. So ultimately you have to remember this. So this method is called as a method of regular falsy or regular falsy method or method of cos. Okay. So for this one, just take this graph map as it is. It is origin and y-axis, x-axis. Okay. So somewhere here I am taking one point, which is nothing but some x. Cross x1. And next is y equal to f of x. This is nothing but the point b comma f of b. Okay, and here somewhere again we will get that x2. Okay, you have to remember these points. And what is the 0 point? This is b comma f of b means here we will get that this point a comma f of a. Okay. So now here I am going to discuss one application. Now write down solve x cube equal to 2x plus 5 for positive root by regular falsy method. Okay. ORR. Actually here what they gave us, the function value is x cube is equal to 2x plus 5. In another way there is a chance to mention that x cube minus 2x minus 5 is equal to 0. This is nothing but f of x. Okay. So first of all here what we have to do? We have to take the value of the, first of all I will explain the procedure and afterward we will calculate. Okay. So here if you observe this one here, they didn't mention the roots, right? That's why here we have to put x equal to 1, 2, 3, 4 and so on. Okay. And we have to find the interval. Next onwards we have the formula, that is x1 is equal to a into f of b minus b into f of a by b, f of b minus f of a. Then we will get the value of the x1. Next, what we have to do? We have to calculate f of x1. If f of x1 is less than 0, and then we have to follow one possibility, and if f of x1 is greater than 0, then we have to follow another one. Okay. Now, first of all, here, what we have to do? We have to take the values of the x is equal to 1, 2, 3, 4, and so on. Now, 1 minus 2 minus 5 minus 7. 1 minus 7 means minus 6. Next, f of 2. F of 2 means what we get here? 8 minus 4 minus 5. 8 minus 9 minus 1. Same rule. So we can ignore this one. Next, f of 3. 3 cube means 3 3s are 9, 27 minus 6 minus 5. 27 minus 11. Then what we get? 60. Right? So yeah, it is negative and it is positive. Therefore, what we can say? F of 2 has negative sign and f of 3 has positive sign. Therefore, the root lies between. Where the root lies now? Simply 2, 3. Okay. Therefore, closed interval a comma b is equal to 2, 3. Clear? Now I calculated the value of the a and b. Therefore, here what we can say? A is equal to 2, b is equal to 3. Clear? Now we have f of a value and f of b also. Okay. So now here what we have to do? Next, we have to calculate the first approximation. So now here first approximation. First approximation means x1 equal to a into f of b minus b into f of a by f of b minus f of a. Okay. Now, what is a here? A is 2. What is f of b? F of a is nothing but f of a means minus 1. F of a, that is f of 2, equal to minus 1. Okay, next f of b equal to f of 3 equal to 16. Done. So now here I have that simply each and every value like a, f of a, b and f of b. Now I am going to substitute. F of b means 60 minus 3 into f of a is minus 1 by f of b. What is f of b? 16 minus f of a is minus 1 means plus 1. Now 32 plus 3 by 17. 32 plus 3 is 35 by 17. Now x1 equal to, again calculate, 35 divided by 17. So it is 2.0588. 2, 3 we have. So simply it is 2.0588. Okay. So next write down. What we have to calculate here? F of x1 means 2.0588 whole cube minus 2 into 2.0588 minus 5. Now calculate it. 2.0588 whole cube minus 2 into 2.0588 minus 5. So it is nothing but minus 0.3910, which is less than 0. Therefore, f of x1 is less than 0. So when we have x1 f of x1 is less than 0. So here what we have, therefore f of x1 is less than 0. Less than 0 means negative now. So that's why here we have to ignore this value f of 2. So now here and f of b is greater than 0. Therefore, the root lies between where the root lies between now, between 2.0588 comma, what is another value? 3. Okay. Now this is nothing but the first iteration. Now we have to go for the second iteration. Okay. Now directly second iteration, otherwise second approximation. x2 equal to, now here in the place of a we have x1. That's why here x1 into f of b minus this is x1 and this is b. Okay, so now here a is equal to x1. Now what is the formula? B is as it is, f of x1 by f of b minus f of x1. Now x2 equal to, what is x1 ma? 2.0588. F of b is 16 minus 3 into f of this one 0.3910. I am taking, actually next we have one value, so I am taking it is 1. 3 of 0. Minus 1, so minus 0.3911 whole divided by f of b. What is f of b again? 16 minus f of x1, 2.0588. Calci 2.0588 into 16. I am calculating individually. Plus 3 into 0.3911, 1.1733 by 16 minus 2.0588, that is 13.9412. Now take the addition. 32.9408 plus 1.1733. Okay. Sorry, 32.9408 plus 1.1733 whole divided by, directly I am doing 13.9412. Directly you can. Now it is 2.44699 I have. So 69, 2.4469. What is the value of this x2? So wait, actually it is we are getting the maximum value now. Yeah, sorry. Here I took that f of x1. Minus into minus plus 0.3911. It's my mistake. So now here what we get? 16 plus 0.3911. 32.9408 plus 1.1733 divided by 16.3911. Now it is 2.081257. So I am taking that it as 26. Okay. Generally it is enough to take that. 6 on the kabadi up to 4 digits is enough. Okay. So now here we have the value of x2. So now this is nothing but the first class one. In the next class I am going to discuss the continuation of this application. Okay. We will continue in the next class. Thank you.